Good afternoon, and thank you very much. So it's my pleasure to be on this stage and talk about some of the latest happening in the manufacturing industries, primarily in the industry, especially in the AI, GenAI. Since I come from Tata Group, we work a lot with the group companies who are into large-scale manufacturing, and there is a lot happening in the group to adopt the AI and GenAI in a large scale. And then I will just give you a few examples of how we are implementing some of the solutions in some of these industries we are operating in, from steel to car to electronics and so on and so forth. But before that, I'll just spend 5-10 minutes just to take you through where all it started and how the AI and GenAI is taking shape, so that you get a kind of a perspective why I'm taking those examples and what the future looks like. So if you look at it, all started with language. So language is kind of, is the core, or there is a lot of stickiness with technology, with language. So it all started with the language. So the entire human civilization, you can actually break it down between, pre-language era and language era. And once the language started, so emergence of language, you have continuum of civilizations, there is a propagation of knowledge from generation to generation, and emergence of a collective consciousness. And that's where, that's the fundamental building block of intelligence. And technology itself has become the seventh kingdom. As you know, I think many of you will know, there are 6 kingdoms, all these, these biological worlds to the animal kingdom, then there are plants, etc. So the technology is the seventh kingdom. I think that's a very important understanding, because the technology is a different way of solving human problems. For example, an aeroplane, an invention of an aeroplane. So birds fly. There are a lot of, humankind wanted to always fly like birds, but how many ever muscle energy you put, you will never be able to fly at that speed, or you can get a 100-ton of mechanical object onto the thing. So this is technology is basically gives you a breakthrough point of things where you can actually make things fly. And so this is one example where technology brings a breakthrough of from your natural world to the mechanical world. So and language itself, or the technology itself, is a different kind of intelligence. The artificial intelligence, which is not like a natural intelligence, which is actually a artificial intelligence. And okay, I can see that. So this is basically breaking the fundamental notions of how intelligence is actually we have still not fully understood what artificial intelligence is and how it works. So the LLMs, now LLMs is all about these large language models you all know by now, and this has become the new operating system. So this is kind of a new kind of a computing architecture, and the LLM is going to replace the way we know the software at all. In fact, you may not even need an operating system in future. The LLM itself will generate its own operating system to kind of build the complete software stack, which will be able to run by itself. So if you see the compute architecture of the future, the LLM will be the center place. And I will not spend too much time on this, because there are quite a few slides there to cover. So, but there is a challenge in the way the current artificial neural networks work. So this is a very static. It is like you build a model, and then and you use that for getting the inferences. Now the problem with this is very static. It doesn't update itself. So, and it is very different from how the human brains work, because human brains work in a continuous feedback mode, continuous dynamic mode. So it is a way different than the way the artificial neural networks have been designed. And so that's why we are now coming, or we are moving from LLMs to from large language models to large multimodal models to the large action models. So here I bring the word action. So the action is becoming a very important part of the intelligence. And I will little bit elaborate in the further few slides. So from a symbolic AI, we are moving to the cyber-physical systems when these actions are getting integrated with the artificial intelligence system. Now, generative AI with action, so there is a famous book that many of you would know, that elephants don't play chess. I think this is This is an MIT professor who has written this fantastic book, How Intelligence Has to Be Perceived. And there, the entire philosophy of that book is no intelligence can evolve if a system does not interact with the real world. A statically built language model, which is just built on a certain huge number of corpus of data, can never be replacing the way the human intelligence evolved. The AGI, or artificial general intelligence, has to evolve continuously. It is never going to be a massive piece of data working on a huge data center and coming out and churning out with a model which is an AI or going to be a GenAI, which going to be an AGI. It is never going to be possible. So Ian LeCun himself has told that the artificial intelligence system, if it has to be evolved to an AGI, the action has to be part of it. So, which means the AI and action, when these two merge together, we have a remarkable breakthrough. We have a solution we have a set of problems to be solved, which is I previously unheard of. So now let's look at I think with this theme, we can just look at the different levels of progressions of AI. So we generally talk, there are 5 levels of AI. So one is the level 1, conversational AI. So all of us are into that era now. So conversation has become the central place for any artificial intelligence system. There are bots all over the place. The second one is the reasoning AI. Reasoning AI means AI should not only give an inference, but also reason itself. So that's the reasoning part. And this is the second most important aspect of the AI which is coming up. There are a lot of us are working on the reasoning AI part of it because people want to know how AI has taken the decision, why it is taking the decision. We all call it in different names. Explainable AI, responsible AI, all of that are basically the part of reasoning AI. But these two are still passive. That means you are doing it remotely, building a model remotely, and then applying it in the real world. It's still passive. It is still not interacting with the real world. Now, the next 3, the autonomous AI is an active AI. Autonomous AI, it is having some starting knowledge, interacting with the real world, updating his knowledge, and then performing his tasks better and better and better every time. So that is the autonomous AI. Like your autonomous vehicles and some examples I'll show, those are autonomous AI. That is the first active AI you are getting into. Next is innovating AI. So innovating AI is little better or more complex than autonomous AI. Innovating AI, that AI itself develops AI. So it's like it knows how to improve itself. It knows how to generate another model. It can possibly solve a problem it has never seen before. So these are innovative AI. We are still not there, but that's the future. And finally, the organizational AI, where everything is AI. There is absolutely zero human intervention. A complete organization, hundreds and thousands of models work together, interact together, share data, share information, and that's how the organizational AI works. These are the basic definitions of 5 different levels of AI. We are pretty good in level 1. Level 2 work just started. Some level 3 science are still at the very early stage. We are still nowhere there in level 4 and 5. It may take a decade plus or more to get into that level. Now let's look at different types of cognitive architecture. So when you design an AI system, so there are different types of cognitive architecture we talk. The first one is very simple, the prompt engineering. So when the ChatGPT was initially came, first year of its existence, it was all about prompt engineering. Prompt engineering was hailed the new skill of the decade, and it is all people do not need any programming, etc. Prompting is good enough. English-like statements are good enough, etc. So those were the first wave of your architecture. So that is LLM. Then came the next, the chain, which is like you create multiple LLMs and have chain of thoughts, break it down to further levels. So that is your second type of cognitive architecture. Third is the router, where we have now multiple, hundreds probably, have LLMs, and they are connected in different configurations. They're routing kind of a concept. So the complexity part of the solution he doesn't understand can submit the job to the other LLM. They collaboratively solve the problem and then finally assemble the result too. And that's how typically any complex systems work. So divide and solve the problem. So that's level 3. These are called linear acyclic. And then the final 2 are the agent-driven. So we all kind of hear it that today it's an agent-driven system or agent-driven architecture, which is the future. And that's how the evolution of the architecture is going. Agents are going to take over the paradigm of software architecture and engineering. So agents will be having special knowledge. It will use tools. It will use a lot of special skills. So agents are just like a skilled human being who has a knowledge base like an LLM, and it also has a set of hands and legs, which are like tools. Like you have a search engine as a tool, you have a memory query as a tool, query engine as a tool. So these are different tools can be given to that agent who armed with a lot of memory and the LLM knowledge can solve any problem on earth. So that's the whole idea about this next to architecture. So these are 2 cyclic architecture. Again, this architecture can be very complex. A typical agent today, we have implemented one of the solutions for doing a semiconductor testing, and it's a very, very complex. So we have about 100+ agents working together, and almost everything is broken into agents. Each agent works on different, even the smallest of the task is given to the agents. And then we have different strategy of evaluating which agent is giving the correct result, which agent is not giving the correct result. Then one agent acts as a creator, another agent acts as a kind of a critic model or critic agent. So these two will fight together and then come out with a final solution. So this typically happens all autonomously. So that's an example of a cyclic architecture of agent. So these are some of the examples of AI with action. So you have probably know the Rabbit M11 that there was one product which came out. Of course, it didn't do very well because people started returning the product. It didn't work very well because the product was good, very well designed, beautifully designed, the personal assistant, but it was ultimately a ChatGPT under the hood. So it didn't really take off. But the idea is very strong. Idea is powerful. I'm sure they'll be working on it, making it further better. Internet of Things, robotics, industrial. I mean, there are many of these examples. Autonomous navigation is an example of AI with an action. The 3D printing, autonomous manufacturing, these are all examples of kind of AI with action and AI with agents. So this is another, and there are so many, and many of them will come up as you see. Now I'm shifting towards the manufacturing industry or the industry-specific AI. So it is very important for industry to solve AI, GenAI problem on edge. So when I say edge means close to the factory floor or close to where the data exists. There is a very limited scope here to send all the data to the cloud, do something number crunching there, and send the results. Yes, that technology will be there, but it's better ROI. It's a better solution to have inferencing on the edge with on the hardware which is close to your floor. So this is where this slide. The key takeaway is it is not just GenAI which solves the problem. You need multiple things. You need conventional AI models. They are extremely important to solve some of the very hard to solve problems. Then you need bunch of anything all over the days. Yesterday we heard a lot about open source tools, etc. So these are all needed to solve a problem. It is no complex problem can be solved simply. Any complex problem you have to solve, you need to think of hundreds of things. There are hundreds of models, agents, open source tools, conventional AI, GenAI. So there is no single cut solution here. Sorry. So that's how the typical solutions are built. And again, where GenAI comes in picture in an industry kind of a scenario, it helps you to give a context. Say, for example, I put a camera here, then it can scan this whole room, find how many people, what is the count, what are the different classification of different types of color of shirts or dress types and etc. So that first level context is very powerful. GenAI can give fantastically. There is no point in wasting time generating those models, working those models. Then your next problem is you are supposed to identify a specific subject of interest. It could be anything. Say, for example, we are working on some of the use cases of a hotel lobby where the camera scans 24 hours and it identifies, alerts suspicious behaviors, or it profiles the visitors based on their type of, how many of their real visitors, how many they have just coming and sitting there, or how much time it takes to kind of, to solve his whatever problem, etc. So these are the different types of, things can be done. So GenAI is very good in giving that first level context. Then you push the problem to these very specific expert models. So these expert models are actually solving the problem. So for example, you have to find a small, if there is a gap available, is there a gap, or there is a small crack or not, or what is the distance between two kind of holes or number of or pattern of holes, because many of our work happens on the aircraft bodies. So in the aircraft bodies, there are many riveted holes, etc. and all, and the aircraft inspection is one of the most important, and nothing can be missed there. So, and the holes are to be accurately calculated. The dimension has to be calculated. So those will go to you will not be using GenAI for that. You will know, yes, this plate has some 20 different holes and 5 different patterns. This is good enough. Now we'll give it to the other expert model, which will actually count the number of holes or the dimension of the holes or the spacings and the patterns. So that will go to the expert model. So these combinations will definitely work. I need to rush because my time is going. So these are some of the examples of inventory management systems. So there are hundreds of cameras in factory nowadays counting objects at different places. And counting is a big business or big job in any factory, because there are materials moving across. People usually take a note by counting manually, and usually what happens is people do mistakes, they undercount, overcount, and finally, in every company you talk to them, they will have tonnages of material unaccounted, wasted, just because counting is not good. But these systems, when you implement, it's a 99.59% of perfection. There is absolutely no problem of counting. So counting is a big business, and that data goes to the inventory management system, the production planning system, the whole thing gets connected, things churn much better, smoothly. Then we have safety monitoring systems, which is AI-based monitoring of customer side. The first part is not very important. It's a simple job of tracking things over the cameras and how many incidences, but the GenAI comes in summarizing it. So one of the challenge today, many of our customers talk that I get too many reports, too many dashboards, too many alerts, too many notifications. I can't do anything with that because I am lost. There are 100 screens I have to see every day, which is, I always miss actually what should I look for. That is the biggest problem today. People are now, all the people concerned, they are flooded with data. But how to take actions from the data is very important. So this is where the GenAI comes in. It actually solves that summarization problem, and GenAI, by miles, fantastic in doing a summarization solution. Anything you give, it summarizes. Of course, you need to check for the validation and other things, but for summarization things, it is fantastic. Assembly line inspection. So again, there are people, and assembly line inspection is a very common thing in any factories. So where people typically, the inspectors or a quality inspector will go, they will note down the snags, they will type it down in a computer, and then it will get updated into the snag list, and then all this. But the problem is, many a times, what they write in the note, they'll put it in the pocket, it will get lost, those snags are gone. So here, the thing is automated. All the guy, now in this system, what this guy has to do, that he has to just keep speaking whatever he sees. This is missing, that is a problem, there is a paint scratch, this part of the tire is not clean, or there is some scratch mark here, there is a deburring marker here, so all that. So whatever he says, it gets collected, it gets pushed to the server, and automatically this thing. So these are some of the examples of, completely automated, zero touch, zero writing kind of solutions. Of course, these are some traffic monitoring systems in the thing. It counts the types of vehicle, it counts the types of like you can actually zonify the whole thing, like this particular zone, how many people are crossing, what type of vehicle crossing. Between this time to this time, any vehicle of that type has to be is crossing or not, etc. So there are, these solutions are becoming very, very commonplace nowadays. It uses multiple types of lidars, and any lidar-based AI is a much more different job than your normal video processing stuff, because there is a very different three-dimensional data you have to handle. Yeah, so these are some of the examples. And this is another example of preventive maintenance of traction motors, which are typically used in some of the Indian Railways systems. So what typically happens is, what is the maintenance cycle of these motors? This is always very difficult, because either you overdo it or you underdo it or never do it. So, and today's systems, or many of the systems, people look for vibration, noise, those kind of things. But here, we are trying to do is with the motor current signature. So it's basically you see the variations in the armature current, and from the armature current, you can actually identify 6 or 7 different types of major common types of failure. It typically is the bearing failures, or the brush motors failure, and if there is any wearing issues inside, some of the insulation has gone in the motor, so that will show up in the flux profile of the motor itself will be completely different, and it will all show up. So you can train the whole model to kind of understand all this and find what type of defects these are. So yes, these are some examples, and so action generation of robot is another type of thing. So where you don't need to. So So anyway, I'll hold it. So any robotic programmers, how difficult it is to program a robot, do the motion planning, path planning, energy optimizations, localization, slams. So these are very, very complex competition problems. So today, with the advent of GenAI, we are able to generate actions. So you can just write normal English-like instructions, and it can do all the jobs. So it actually writes the entire code, the entire fault tree. If this robot interacts an obstacle, how it should do, how it should navigate, etc. So these are some examples of how these will be. These are some examples of how action generations can actually help. Digital twin is very much part of any manufacturing system nowadays. So digital twin and AI, they are very closely related, and they always go together, because when you have to digitally represent a physical system, you have to build the models for those. So any of these models, which is kind of, they are all designed in a way that it replicates or it kind of mimics some of the performance characteristics of the device, and you can actually, even before anything happens to the real-world machine or a component, it actually shows up in your digital twin. So you are much better equipped. You have a complete view of a predictive system built, which actually gives a very complete view of what is going to happen in your system. So the digital twin is very important. And there are any digital systems today, a complex system today will have at least 20, 30 different AI models running inside, for sure. Then digital twin for EV battery. In Tata Group, we have one of the very success story of using electric vehicle and EV cars. We are the pioneer, and there is a lot of work happens in the background for the battery, because that is the core thing here. In EV battery, there is nothing other than battery. I mean, I'm just exaggerating a bit, but the battery is the main thing, and a lot of technology and things goes to kind of understand how the battery is performing. So there is a complete digital twin has been built. So, and you know that any of these vehicle batteries, there are thousands of cells, and each cells will be 1.5 kind of a volt. So you can, if you have some certain kilovolt requirement, so you can imagine how many thousands of batteries will be there. And these batteries come from different suppliers and different things, so there will be certain manufacturing differences here and there. So their charging discharging cycle will never be the same. And because of that, some cell will go down faster, some cell will live longer, but that creates the maximum problem. So if you have very unbalanced or unequal kind of a charging recharging cycle, so that becomes a potential fire risk. and some points will get overheated, and you'll have all sort of problems. So that's why the very important to understand what happens inside a battery, how the charging is happening, which cell is performing well. So battery is not a single monolithic block. So these are micro cells you have to monitor. So you have to do a cell-by-cell monitoring, planning, and data collection, etc. So there are a lot of hardware and data collection system is built around to kind of get those data and kind of push that data to a system and then get all those information so that your car is safe and your battery performance is lifelong and increased beyond your expectation. These are some of the examples of how the complete safety training has gone to digital mode. So there are a lot of the VR training happens nowadays thanks to those VR sets. Today we have MetaQuest and Oculus, etc. Devices. So a technician actually can see the whole system and can actually, I may not have the full time to kind of go through this video, but it is a nice experience, kind of how. Maybe I'll just play 2 minutes. So this is a car showroom. So you can take a virtual drive. Yeah, there are plenty of other examples I'll skip for the paucity of time. This is another example of in a hospital we are working on. So this is an emergency room protocol in hospital. So this is any hospital emergency room. There is a lot of chaos, a lot of very difficult cases come in. So this is one case where if a cardiac patient with almost no pulse has come, so what to do? And sometimes what happens in the emergency room, we'll not have the right doctor, right practitioners who are actually always equipped, because there will be sometimes late night, trainees will be there, and nurses will be there. So they'll not be knowing what exactly to be done with that kind of a serious patient whose life is at threat. So there are a lot of SOPs which are used in the hospitals, like if a cardiac patient happens, what actually to be done. So this whole thing is now coded in the language, and there are a set of couple of cameras which is optional, and a set of audio devices which actually records everything the nurses are saying, and it also gives instruction, like the patient has a pulse, do this, do these injections, do a CPR. After 3 minutes of CPR, do ABCD things. And then if it is not recovering, then do this, etc. So this whole cycle continues till the patient is recovered and he or she has become stable. So, and then at the end, it also makes a nice summary. So that summary has all the details which has happened. It's kind of almost like a black box of a airplane. So what all happened in the emergency room. So the doctor can have a look, and the summarization actually helps to understand what all procedure has taken place, so that next course of medical actions can be taken up. Yeah, so I'll just give 2 point of views, just 1 minute left. So the overall industry outlook is like some of the high impact GenAI use cases are like summarization, of course I talked about, customer support, digital marketing, inspection. These are like a clear winner. GenAI is doing fantastic job. Copilot for skill intensive. Copilot has become a kind of a habit-changing technology. Anything you want to do, you always look at, is my Copilot saying? Even if it is a simple English letter you have to write, you just go and ask. You just give some 2-3 sentences, and it is all becoming a habit. So it's a habit-changing technology. It is going to stay. It may not be that great for some of the areas, but that habit is going to remain. So it is going to be there. 40 to 60% productivity gain is seen for POCs, but when it comes to the production, there is always a drop. So I think that challenge has to be solved. And human in loop is going to be there for some time. So humans are not going to be replaced for quite some time, at least 5-6 years. Going forward, yeah, so this is my summary. 2023 was, year of explorations, a lot of education. Everybody started to learn what is these new terms, LLM, etc. A lot of education for yourself, and then inspirations. 2024 is a lot of use case build up, POCs, lots of spending, some wow moments, and a lot of limited results. 2025, more cautious approach. So going forward, I think the focus will go to robust frameworks, focus on tools, validation techniques, ROI is coming or not, and all that. And then some of the points I already covered, that is going to be the action models, the sovereign AI. A lot of my speakers earlier talked about that. Enterprise class agents architecture, autonomous agents. So it is going to be the future of the agents. And with that, I end, and thank you very much.